Hello guys, welcome to Success Station, and this is the third series in the numericals in beams where we'll be finding the reactions in uniform varying loads. So let's get started. So the question says calculate the reactions for the beam subjected to the loads as shown in the figure. Now हम लोग देख पा रहे हैं यहाँ पे कि ये ट्रायंगुलर लोड है यहाँ पे और दो यहाँ पे सपोर्ट्स हैं A और B. A हिंज है, B रोलर है, ठीक है, और 2 किलो न्यूटन का ट्रायंगुलर लोड लग रहा है यहाँ पे. तो यूनिफॉर्मली वैरिंग लोड को हम लोग ट्रायंगुलर लोड भी बोलते हैं बिकॉज इट अपीयर्स सेम लाइक अ ट्रायंगल. और हम इसको सॉल्व करने के लिए ट्रायंगल का ही हेल्प लेंगे, ट्रायंगल के ही दो प्रॉपर्टीज का. तो हम लोग देखते हैं कि हम लोग को ट्रायंगल का हेल्प क्यों चाहिए यहाँ पे, बिकॉज यहाँ पे 2 किलो न्यूटन पर मीटर का लोड है. तो जो हम इसको क्या करेंगे, जैसे हमने यूडीएल में किया था कि हमने जो भी डिस्ट्रीब्यूटेड लोड था उसको एक सिंगल कंसंट्रेटेड लोड में कन्वर्ट किया. अभी अगर हमको यहाँ पे वैरिंग लोड है, ट्रायंगुलर वैरिंग लोड है, इसको भी हमको एक सिंगल कंसंट्रेटेड लोड में कन्वर्ट करना है. तो सिंगल कंसंट्रेटेड लोड में कन्वर्ट करने के लिए हमको क्या चाहिए, हमको चाहिए दो प्रॉपर्टीज ट्रायंगल के. तो हम यहाँ पे देख पा रहे एक ट्रायंगल है एबीसी का जिसका हाइट h है और बेस b है. AB इज द बेस, BC इज द हाइट. तो उसका एरिया क्या होता है ट्रायंगल का, एरिया ट्रायंगल का होता है 1/2 इंटू बेस इंटू हाइट. ठीक है, ये याद रखने का आपको अपने को हमको पता ही है, बट फिर भी यही प्रॉपर्टी का यूज है. एरिया ऑफ ट्रायंगल इक्वल टू 1/2 इंटू बेस इंटू हाइट. और दूसरा जो प्रॉपर्टी है ये मीडियन है. मीडियन है कि सी पॉइंट से हम एक लाइन ड्रॉ कर रहे हैं ए बी के ऊपर सच दैट कि ए बी को वो एग्जैक्टली 2 हाफ्स में डिवाइड करता है. तो सेम है ये लाइन, सेकेंड लाइन जो ए से ड्रॉ की हम लोग, तो वो सी बी को एग्जैक्टली 2 हाफ में डिवाइड करता है. सेम इज द थर्ड लाइन बी से ड्रॉ किए हैं जो कि ए सी को 2 हाफ्स में डिवाइड करता है. तो हमको ये तीनों लाइंस, दीज 3 लाइंस आर कॉल्ड मीडियंस ऑफ अ ट्रायंगल. ओके, एंड जब ये तीनों मीडियन एक पॉइंट पे हमेशा मिलते ही हैं, अगर वो मीडियंस हैं तो वो एक पॉइंट पे मिलेंगे ही, दैट पॉइंट इज कॉल्ड सेंट्रॉइड. ओके, एंड इफ वी ड्रॉ अ लाइन थ्रू द सेंट्रॉइड, straight line perpendicular to the AB, then it divides the base into ratio 2:1. Yes, this is the property. The perpendicular line through the centroid of the triangle divides the base into the ratio 2:1. So यहाँ पे रेशियो क्या हो जा रहा है, AD is to DB equal to 2:1. So AD will be equal to 2/3 into AB. And dB will be equal to 1/3 into AB. Now we have to clearly remember these two properties of the triangle because in uniformly varying load we'll be using the two properties itself to get the concentrated load out of the uniformly varying load. Okay, so I will repeat once again that the straight line from G to D which is perpendicular divides the base AB into 2:1 ratio. Okay, so AD becomes 2/3 into AB and DB becomes 1/3 into AB because AD is to DB equal to 2:1. Okay, now we see the question once again. There was 2 kilonewton per meter, 3 meter span, two reactions RAX and RAY and RBY. RAX and RAY because the hinge support is there, so one horizontal reaction and one vertical reaction, and RBY because only one reaction and that is due to the roller support. Okay, now further अभी हमको ट्रायंगुलर लोड को सिंगल कंसंट्रेटेड लोड में कन्वर्ट करने के लिए क्या हमने देखा, एरिया ऑफ ट्रायंगल क्या होता है 1/2 इंटू बेस इंटू हाइट. तो यहाँ पे बेस, अगर हम ये ट्रायंगुलर लोड को एक ट्रायंगल मान ले, राइट एंगल ट्रायंगल, तो बेस क्या है 3 मीटर है, हाइट क्या है 2 किलो न्यूटन पर मीटर है. तो 1/2 इंटू बेस इंटू हाइट क्या होगा, मैग्नीट्यूड. तो वो मैग्नीट्यूड आ गया हमारा, दैट मैग्नीट्यूड विल बी 1/2 इंटू 3 into 2, that comes out to 3 किलो न्यूटन. तो ये जो हमको दिख रहा है यहाँ पे बड़ा लोड, the whole concentrated load instead of the uniformly varying load will be 3 kilonewton. Okay, and at what distance it will act? It will act at a distance of 2 by 3 into 3 meter, that is 2 meter. Okay, the whole span is 3 meters, that is the base is 3 meter. So 2 by 3 of base, because हम लोग A end से निकाल रहे हैं वो distance, अगर हम B end से करते तो it will be 1 meter. Okay, so we'll now use the equation, equilibrium equation, the first one, ma equal to 0. Now ma equal to 0 करके क्या आएगा हमारा 2 kilonewton per meter into 1 by 2 into 3 meter. This is the magnitude of this big load. Okay, we are taking moment about A. So 2 kilonewton per meter, 2 kilonewton per meter into 3 meter. This is 3 meter by 2. This is the base 3 meter. This is the height 2 kilonewton per meter. 1 by 2 into base into height, that is the magnitude. तो ये part जो है 3 by 2 into 2 gives the area or the magnitude of the concentrated load. Okay, now the second part which is कि how much distance this load has. This is 2 by 3 into 3 meter. 3 meter is this hole, so 2 by 3 into 3. Okay, so we get another moment due to this about point A. But point A is in this direction, which is clockwise direction, so it has to be positive, and the moment about A of RBY is anti-clockwise, so negative, and the distance from RBY is 3 meter. So we get this, we get the answer as RBY equal to 2 kilonewton. Okay, so we got our RBY. Now we use the second equation of moment, second equation of equilibrium, which says Fy equal to 0. Now Fy equal to 0 will get what? There are two reactions, RAY and RBY, and one load whose magnitude as we know is 1 by 2 into base into height. Height is 2 kilonewton per meter and base is 3 meter. 1 by 2 is the formula, 1 by 2 into base into height. So we get RAY equal to 3 minus 2, because RBY we have found out 2 kilonewton. So we get RAY as 1 kilonewton. Okay, and the third equilibrium equation says what? Fx equal to 0. So there is no other force in the x direction except Rax, so Rax will be 0. Okay, we got the three answers. So this is how we solve it. We have to convert the triangular load into a single concentrated load with the help of the formula 1 by 2 into base into height, because it's a triangular load. So we get by that, and the centroid formula 2:1. Okay, I hope you get it. Okay, we'll solve one more then. Now calculate the reactions for the beam subjected to the load as shown in the figure. Earlier we saw there was hinge support, there was roller support, but this is different beam. This is a cantilever beam. So what happens in a cantilever beam? The free body diagram will be different in this way such that because this is fixed about this point at point B, so all the loads that are acting, these loads that are acting on the beam are trying to move it in this direction, but the reaction has to oppose this thing, so the reaction will act in this direction. Okay, this we'll see in the free body diagram. So as you can see in the free body diagram, the reaction is acting in this direction. Okay, and one vertical reaction RBY, this happens in the cantilever beam. So one moment and one vertical reaction. Okay, now let's see. We'll take now the moment about point B. We have for the previous triangular load we used the moment about point A. Now in this question we'll use the triangular load. For this triangular load we'll use the moment about point B. So equilibrium equation about point B, we get MB equal to 0. Okay, moment about point B equal to 0, what we get, this is the moment, so we'll write as it is. Okay, we are taking moment about point B, but so RBY, moment due to RBY will be 0 because the distance from B to RBY is 0. Okay, but the moment at point B will not be 0 because at that point no distance is multiplied. Okay, so moment at point B will be there, which is anti-clockwise, so which is clockwise, sorry, and so clockwise moment MB plus the moment due to single concentrated load of the triangular load. Okay, so what we have to do for that, we have to convert it into the formula, which is 1 by 2 into base into height. Okay, this is the magnitude, and from B the distance will be, सेंट्रॉइड का याद है ना फॉर्मूला हम लोग को, तो हम लोग यहाँ पे 2:1 में डिवाइड कर रहा है, तो यहाँ पे B पॉइंट से डिस्टेंस क्या होगा, 4/3. ओके, दैट्स व्हाट वी आर गेटिंग. ओके, 4/2 into 3 into 4/3, we get the answer as 8 kilonewton per meter. So now we'll apply the second equilibrium equation, which says Fx equal to 0. Now Fx equal to 0, as there is no horizontal reaction acting, so Rbx will be 0. Okay. And third one, Fy equal to 0, so Rby equal to 3 into 4/2, that is 1/2 into 4 meter is the base and 3 kilonewton per meter height. So we get easily Rby equal to 6 kilonewton. Okay, there are only two forces, one upward and one downward, so they both equate each other and we get the answer. So this is the way to solve it, solve the uniformly triangular loads. Now this will help us in solving the numericals, finding reactions in trusses also. So do remember this method and keep practicing, and thanks a lot. Do subscribe to Success Station. Thank you.